people who aren't able to make it. Okay. So I'm recording this and I'll post it to Canvas later. Okay. So any questions about the exam?
Yeah. Oh, sorry. Go ahead.
I was just wondering how the format of it's going to be like.
The format, is that what you said?
Blank or...
I can't hear you very well.
Oh, can you hear me better now?
Yeah.
Okay. I was just wondering how the format of the test is going to be, like if we're doing multiple choice or fill in the blank or.
Okay. So I'm going to do multiple choice for like 20 something questions, and then at the very end I like to do just having you draw structures. So I'll give you either well, usually I just give you a name and then you draw the structure, and then I also like to do reactions. So I'll have a page of structures and then a page of reactions for you to do and complete.
Okay, thank you.
Mm-hmm. And Jamie, you had a question?
Yeah, you just answered it.
Oh, okay, great. Okay, anybody else?
How many questions do you normally have on the exams?
I honestly can't remember. I think it was 25 multiple choice and then a page of structures and a page of reactions. I think that's what I did before, but I don't know an exact number.
Thank you.
Okay, so I'm just going to go through the review that I put on Canvas. Just kind of talk about what we talked about in each chapter, and if there's any questions, be sure to ask. You can interrupt me, that's fine. And so anyway, I'm just going to go through the chapters. I'm going to share my screen here. Okay. So in the first chapter was all about alkanes. And we looked at carbon because, organic chemistry is the study of carbon compounds. So we looked at organic versus inorganic, and, some of the characteristics of organic molecules compared to inorganic. So make sure you know the difference. Kind of similar to one of the questions I gave you on your, I think it was on the alkanes virtual lab. Okay. I don't want you to memorize all the functional groups from chapter 1. We're going to be memorizing them throughout the semester, so there's no reason to memorize all of them now. You just need to know the ones that we've covered in the chapters. There's the general formula for an alkane. I do want to say, so drawing structures, so structural formula, condensed formula, and line structure. I got a lot of incorrect structures on the labs. I was trying to be, easy on you because that was kind of our first round. But I am going to start requiring you to draw the correct structure. So if I ask for a structural formula, please give me a structural formula. A condensed structure is not a molecular formula, okay? So make sure to go over that and be sure to give me the correct structure. And then the line structure. So anyway, so be careful on the test. Make sure you read what structure I'm asking for and give me the correct structure, because I will take off if you don't give me the right one.
Could you go ahead and just like really quick, just draw what each one of them are, each three, just like a.
Sure. Let me see if I, oops, let me try and join with my phone so you can actually see. This might take me a minute though.
Sorry, I just thought it'd be easier just to make sure we're all on the same page.
That's totally fine. Just take me a second here. Okay. Okay. Okay, I think I got it. Okay. Hold on. Hold on. Ooh. Okay. No, still doing it, isn't it? Is that better? Nope. Okay, can you hear me from this one? Let's try this again.
I can
It's
hear
still
you, but
echoing quite a bit.
What'd you say? I'm sorry. Oh,
It's still echoing quite a bit, even when you have one of them muted.
okay, let me try this one more time. It's still doing that. Okay, I don't know what's going on. That is not going to work. Okay, I'm just going to draw it and then hold it up to my computer camera and see if that'll work. So I'm
Sounds
just
good.
going to draw propane. So first I'm going to draw the structural formula. So with the structural formula, you should show the hydrogens spread out around the carbons. Okay, okay, so let's see if we can see this here. So this is propane's structural formula. You see that okay?
Yeah.
So that's the structural formula. And then I'm going to draw the condensed formula. So the condensed formula still shows how the carbons are connected, and it's not a molecular formula. So here's the condensed formula right here. You see that one?
Yes.
Okay, that's the condensed formula. But I'm going to show you what the molecular formula is real quick. So the molecular formula would be like this. See the difference between condensed and molecular?
Yes.
Okay, I don't want molecular formulas. I want condensed. And then last of all, line structure. I think we have down is this one right here for propane.
Okay, thank you.
And then I just want to one more show a ring because I got a lot of line structures when it was asking for a condensed formula for a ring. So just to show you real quick, if I had a 6-carbon ring, okay, it will look like, there it is, that. Okay, so you still need to show it as a ring and show the carbons and the hydrogens. Okay.
Thank you.
Okay, let me get back to the review page. Okay. And okay. Isomers versus conformers or conformers. Isomers have the same molecular formula, so they're made up of the same thing, but they have a different arrangement. Okay, so they're not going to be the same molecule. I gave some examples for you in your worksheet for chapter 1. So if it's the exact same molecule, then it's a conformer. So it has the same molecular formula and it has the same arrangement. Now the rotation might be different. Remember with alkanes, we can have rotation around the carbon-carbon bonds. But it's going to be, the carbons and the hydrogens are all going to be attached the exact same way. That's not the same for isomers. Okay. And then naming. So be sure you have naming down really well. We're going to obviously be doing a lot of that. We've done a lot so far. So naming straight chain alkanes or branch chain alkanes. So that's when you have to name your alkyl groups or your substituents. Make sure to go over your prefixes, the iso, tert, sec, for especially propane and butyl or butane. And then I just put the rules out on here for you. So find the longest continuous chain and then name it according to, you know, how many carbons there are. Then we number the carbons that are nearest to the first branch, and then identify your substituents and write the name as one single word. Make sure to put commas between numbers and hyphens between numbers and words. And then list your substituents in alphabetical order. Okay. Oh, I have more rules down here. So we want the chain that has more substituents, so the longest chain with the most substituents. And then give the second substituent the lower number possible. Okay. Properties of alkanes. So alkanes are nonpolar. So they're not going to dissolve in water. They'll dissolve in a nonpolar solvent. And as the molecule gets bigger, the melting point and the boiling point increases. So that's because of London dispersion forces. So the bigger the chain, the higher the boiling point. They're volatile, which just means they evaporate. Okay, also in chapter 1, we talked about 2 types of reactions, a combustion reaction. So anytime we have an alkane reacting with oxygen, it produces carbon dioxide and water if it fully reacts, right? Because if it doesn't fully react, we'll get carbon monoxide. And then halogenation occurs when initiated by light. So we have a halogen replacing a hydrogen. So those are 2 reactions that I could put on your exam. What I would do is I would put your reactants and ask for the product, okay? Or I could put the product and ask what started this, or what were the reactants.
Can you do an example of each of those?
Sure. So let's just do, and any hydrocarbon would work. I'll just do ethane reacting with oxygen. Okay, so, sorry, ethane reacting with oxygen here. Can you see that? I may need to go off, stop sharing. There we go. Okay, so ethane reacting with oxygen is going to produce CO2 and water, and I'm not worried about balancing the equation. Okay, you guys don't need to worry about that. So just make sure to give me the correct products, or if I give you the product, give me the correct reactant. And then halogenation, we'll just do methane and chlorine. So we could get CH3Cl. So if I can see right. Okay, so there's methane reacting with chlorine, and the chlorine is just going to replace one of the hydrogens. So again, remember that has to be in the presence of light or heat for it to occur. So it's not like our alkenes where easily reacts.
Can you do that first one again?
Uh-huh.
The oxidation one?
The combustion.
Yeah, the combustion one.
This one's
So,
uh-huh.
and you said, so why is it CH3 if it's ethyl?
I did ethane.
Oh, ethane. Okay.
And
Okay.
then reacting with oxygen. And again, it doesn't matter what your alkane is, you'll always get CO2 and H2O.
Okay. All right.
Okay, let me go back to my screen.
So anytime it reacts with oxygen, it's going to be CO2, H2O, regardless.
As long as it fully reacts, yes. So I'm not gonna, on your reaction sheet, I won't have you write the carbon monoxide one, just the carbon dioxide. Now in the multiple choice questions, I may ask, if the combustion reaction doesn't completely react, what can be produced? And you would tell me carbon monoxide.
And you told us that the addition reactions, those are the only ones that will be asked to like solve out. The other ones we just need to be able to name, didn't you?
I don't remember. On chapter 2, when we talked about rearrangement, substitution, those, yes. These, the halogenation and the combustion, I could ask you to write out. Does that make sense? You know what I'm talking about?
Yes.
Okay, great. So we'll talk about that more when we get to chapter 2. Okay, so then we have cycloalkanes. So those are the carbons in a ring. So we name cycloalkanes similar to alkanes, except we add cyclo to the name so that we know it's in a ring. So we have right here prefix, cyclo, parent, suffix. So if you only have one substituent on the ring, you don't need to number it because it will be on carbon 1. But if you have more than one substituent, then you will need to number it or put the, no, I guess we didn't do that. Never mind. You'll need to number the substituents. And we want to give the second one the lowest number that we can. Okay, any other questions about chapter 1? I can't see the chat. Let me make sure. Okay. Okay, then we'll move on to chapter 2. Okay, chapter 2 is alkenes and alkynes. So alkenes have a double bond, alkynes have a triple bond. So when we name them, we have to find the longest carbon chain that has the double bond or the triple bond in it. And if it's a double bond, then we add the suffix "ine." If it's triple bond, we add the suffix "-ine" to the parent chain. And you always need to number where your double bond or triple bond is. Somebody have a question?
Yeah, I have a quick question on that. If there is a double bond and a triple bond, do you just put the one that's first in the chain to name it?
Trying to think. I think we did. I did like that.
E&E. And so I just
I did what? I'm sorry.
Sorry, I'm far away from my computer.
Oh.
Let me. In class we did 1 heptene, YN, and then 3 E&E. So I just wanted to know if you put it alphabetical or you put the one that comes first.
I honestly can't remember, and I don't have my stuff. Let me look that up, and then I will post that on in the announcements because I can't remember.
Okay.
And I did not plan for staying at home for 2 weeks, so I didn't bring any of my stuff home. So yeah, I'll look that up today and I'll post it in the announcements. Let me write that down. Okay, good question. Okay, then we're going to start numbering the chain closest to the double bond or the triple bond, and then write the full name, including the substituents alphabetically like we did with alkanes. I think that's it. So basically name them the same as alkanes, except for we're giving the double bond and the triple bond priority in the numbering of the carbons. Okay, cis-trans. So remember with cis-trans, I told you, I know your book does a little bit different, but we're just looking for the hydrogens, okay? So if they're on the same sides, I remember side was top and bottom, the ends are on the sides, which is confusing, but so as long as the hydrogens, if they're on the same side, then it's cis. If they're on opposite sides, then it's trans. So just look for the hydrogens. If there are no hydrogens and I ask, can this have cis-trans, then tell me no. Okay, hold on one second. Okay. Okay. And then the properties of alkenes and alkynes are similar to alkanes. They're both nonpolar, just like alkenes were. They're insoluble in water, but they are soluble in nonpolar solvents. And the thing that's different from alkanes is they are very reactive at the multiple bond. So alkanes weren't super reactive. I mean, we had a couple reactions, but alkenes and alkynes are much more reactive at their multiple bond. So we just talked about the different types of reactions, addition, elimination, substitution, rearrangement. So those are the ones that I said you won't have to actually draw out. I would just give you the full reaction and say, what type of reaction is this? And you would label it, okay? So addition reaction, we're gonna do a lot of, we have a lot of it, we looked at a lot of those reactions. So those you will have to write out. Elimination reaction, you just, again, need to recognize it. So it's basically the opposite of addition. So you have a, start with reactant and then end with two products or more. Substitution reaction, you just have like our halogenation, where the chlorine is substituting for the hydrogen. That would be a substitution reaction. Sorry. And then rearrangement reaction is the same molecule, but there's rearranging happening on the molecule. So go through those. You don't need to write them out, except for the addition reactions that we're going to talk about. You just need to recognize them. Okay, so here's the ones that you are going to have to write out. Hydrogenation, sorry. So here we have hydrogen being added to the double bond. So basically you're just taking the double bond out. And, halogenation, we have either bromine or chlorine or iodine attaching where the double bond is. So to the carbons that have the double bond or the triple bond also. So those halogens will attach there.
I think Nicole is in the waiting room for the Zoom.
Okay, I let her in just a second ago. Did she go out? Let me see. I can't.
Oh. No, I just got in. Thank you,
Okay.
though. Thank you. I was in the waiting room and I couldn't get in.
Okay. Did you get kicked out?
Yeah, I lost power at the dorm, so I've been getting logged off and logged back in. It's a hassle.
Yeah. Oh, the joys. Okay, let's see here. Then we have addition of HBr or HCl. So that's where we have to follow I can't ever say this guy's name, Markovnikov's rule. Yeah, I think I said it, Markovnikov. So hydrogen and bromine are added to the carbons that are in the double bond, but hydrogen is going to be added to the carbon with more hydrogen, and then the halogen will be added to the carbon with less hydrogen. Now, if they have the same amount of hydrogen, it doesn't matter which one you do. Okay, you can do both. And then the same thing with hydration. Remember, it's adding water, but think of it as HOH. Okay, so hydrogen will be added to the carbon with more hydrogen, and then OH will be added to the carbon with less hydrogen. So again, those will be on the page of reactions in the back of the test, or towards the back of the test, that you'll either have to give me the reactants or the products. Okay, so make sure to go over those really well. Alkene polymers, I just mentioned really. I'm not going to ask a whole lot on alkene polymers, but we know that they're made by monomers, repeating monomers, repeating units. And we kind of went over how they're attached to each other. I'm not too worried about that. You're not going to have to draw that or anything. Just know that they're made up of the monomers and that they can have, I can't remember how many units I said, thousands of units. So that's, I mean, just kind of skim through that. I'm not going to ask a whole lot of questions on polymers. Aromatic compounds. So these are the benzene rings. So they have the 3 bonds on the 6 carbon ring. So you can draw it with the bonds, or you can draw it with the circle like we did. Either way is fine. But again, make sure if I'm asking for condensed structure to give me the condensed structure and not the line structure. Okay, and if I don't ask specifically, I don't care which one. Okay, if I don't say, you know, draw the condensed structure, and I just say draw the structure of this, then you can pick whichever structure you want to draw. Okay, so naming aromatic compounds. Remember, with mono-substituted compounds, we don't need a number. Okay, remember it's always on carbon 1. Di-substituted aromatic compounds, we can use the ortho, meta, para, or you can use the numbers. If I ask specifically for ortho, meta, para, then make sure to give it. But if I'm not asking specifically, you can use either one. Know the common names of toluene and aniline and phenol. Those are the 3 that we talked about. There were 2 others that were mentioned, but I told you not to worry about those. Just those 3 are important.
Professor Nikki, I'm sorry. What do you like? So if you ask for ortho, meta, para, are you gonna say ortho, meta, para, or are they called something? Like, is that? Are you gonna? Because that's where I've been thrown off a couple times, where you'll call it something, and I'm like, well, what is that exactly? I know what para, ortho, meta is, but
I can't remember. Is it? Let me see. Sorry, I just don't have my stuff with me. So let me look real quick.
I think on my notes I have it as relational descriptors.
Okay.
Is that what it is?
That sounds right. I just can't remember the specific name.
relation what?
Descriptors.
Relation descriptors. Okay. Thank you.
Let's see here. Okay, well, we'll go with that because it's going to take me a minute to find it.
So if it's on the test, it'll be like, name this with the relationship descriptors?
Yes.
Okay.
Okay, let me go back to my screen here. Okay. Oh man. The meeting's going to end in 10 minutes, and if we're still going, I'll post a new link for and open up the meeting again. Okay. So just go to the. I'm sorry.
I just have a question about the other exams. Since this one was pushed back, will everything be pushed back?
Yeah, we're gonna have to figure that out. I don't know. I still need to look at it, so I'll let you know for sure.
Okay.
So if the meeting ends, I'll post a new link in the announcements and you can rejoin, okay? Okay, let's see here. Okay, so the common names, and then we'll identify the parent. So it's either gonna be phenol, toluene, aniline, or benzene, okay? That'll be the ring. But we could also have a benzene ring as a substituent that we talked about. So it'd be phenyl is the name for the benzene ring as a substituent. So if you have a carbon chain that's longer than six carbon, and you've got a phenyl or a benzene ring attached to it, then it would be considered a substituent. Okay.
I did have a question on that. I'm glad you brought that up. So when you have toluene, which we had it, where did I put it? It was, crap. Okay, I can't find it right now. But so toluene, like the CH3 and OH were on a benzene ring. How do you know that it's a phenol? How do you know that the parent name is a phenol?
So OH will take priority over a methyl group. So it would be named phenol instead of toluene.
Okay, so
and aniline both would take priority over the methyl group.
Okay, so then what if it's aniline and phenol?
Phenol would take priority, but I'm not going to put both of those on there. I may put methyl with those, but I won't put NH2 and OH together.
Okay, thank you.
A second ago, you named that we needed to remember toluene and a few other things, but I did not catch the other things you named.
Toluene, phenol, aniline, and benzene. Those are the 4 that we can name the benzene rings. Okay, any other questions?
I have one. Sorry. So in the notes, it says that for the benzene ring to become a phenol, like the substituent group, the parent chain had to be more than, it was either 6 or 7, I believe. But yeah. on the worksheet, you did a problem. Sorry, I'm trying to find it. Oh yeah, it was 3-phenyl-2-butanol, and the parent chain was only 4.
3-phenyl-2-butanol?
Yes, ma'am.
Okay. Yeah, I have to look at that one. Let me get back to you. Who's asking me this? I don't know.
Catherine Hotchkiss, sorry.
Oh, you're good.
Well, but it was phenol, not phenol, not OL. It was with a YL. Does that make a difference?
Yeah. So I'll just have to look at that one because I'm not sure. Is that on chapter 3 or chapter 2?
The question, like on the worksheet, was on the chapter 3 worksheet, but I'm not sure if the note part was in chapter 2 or 3 notes. Okay. I think it was in chapter 3, but I couldn't. I just looked for it in chapter 3 and I couldn't find it.
Okay. Let me. It's hard for me to say without seeing it.
Yeah.
And then I can post that in announcements or just send you a message with the answer. Okay.
Thank you.
Wait, is it? It's 3-phenyl-2-butanol with OL at the end. Would the phenyl be a substituent group because there's an OH attached, which would make the butane group the parent chain because it's an alcohol?
Yeah, that's what I was thinking. It's just hard for me to say without seeing it. Because the alcohol group will take priority. Because remember, phenol is not or benzene ring. So the alcohol would take priority over the benzene ring. Because when we name alcohols, we name them with where the OH group is in. Does that make sense?
Okay, so if it's an alcohol, it doesn't have to be over 6. The parent chain doesn't have to be over 6.
No,
okay.
How we number the double bonds and the triple bonds, we have to number it with the bond in that chain. Same thing with OH. So when we're naming alcohols, we pick the longest chain with the OH in it.
Okay, that makes sense.
That's probably the thing. Thank you, whoever helped me out on that one. Okay, let's see here. Okay, then the reactions, there were 3 reactions for aromatic compounds: nitration, halogenation, sulfonation. So nitration, we were adding the nitro group. Halogenation, we were adding halogen. And then sulfonation, we were adding that weird SO3H group to the benzene ring. Okay, so just be able to do that. And remember, it doesn't matter where it goes. It can go in the ortho, meta, para position. So it doesn't matter. You can stick it wherever, you know, if there's something already on there, like we did an example with a phenol, or I think we did one with aniline. So you could put it in the ortho, para, or the meta position. Okay, chapter 3. So hopefully you've gotten through all of chapter 3. If you haven't, make sure to finish that up. It's all about alcohols, which has an OH group attached to the carbon chain. Phenols have an OH attached to an aromatic ring, but again, phenols are not alcohols. And then an ether has carbon chain on both sides of an oxygen, so that's the ROR. So this would be a carbon chain. This would be a carbon chain. And then hydrogen bonding. So alcohols and phenols can hydrogen bond, but ethers do not hydrogen bond with themselves because they don't have a hydrogen attached to the oxygen. Okay. And I think in your notes, oh, never mind. I have them down here. Never mind. Getting ahead of myself. Okay. So naming alcohols, we're going to name the parent compound with the longest chain that has the OH group, like we were just talking about. We're going to start numbering the carbon chain nearer to the end of the OH group. And then write the name with the number of the location of the OH group right before the compound name, right before the parent name, kind of like we did with the alkenes and the alkynes. And then a dialcohol or diol contains 2 OH groups. And then a glycol, so this is a little bit different, be careful with this. A glycol contains 2 hydroxy groups, but they're on adjacent carbons. So that's what, not all diols are glycols, okay? Glycols have the hydroxy groups that are on adjacent carbons, so.
Could you do an example of a glycol?
I think we're about to run out of time. So again, I'll put the new link in the announcement, okay? Oops. Okay, so this would be an example of a glycol. So here's my pencil. Okay, here's the OH group, here's OH group. So these are adjacent carbons. Now, if I had put the OH group over here, that would not have been a glycol. Okay, so let's say if I move this one over here, it no longer would be a glycol. It would still be a diol, but not a glycol. Does that make sense?
Do we have to name it as a glycol, or can we just put diol as well?
You can just put diol. I may ask you in one of the multiple choice questions specifically for what a glycol is, but naming it, you can just put diol. I know you can put glycol in there too instead,